Hello, pre-calc. Here's the first part of our do now. Quadrant 3 is highlighted in yellow. Go ahead and list the trig ratios that are positive and the ones that are negative in that quadrant. You can hit pause, and when you're done, go ahead and resume. All right, so quadrant 3 is going to have tangent and cotangent will be positive, and cosine, sine, their reciprocals, secant and cosecant, will all be negative. And there's a second part of the do now. 3, -4 is the terminal point of a vector. All right, so the vector starts in the origin and it ends at the point 3, -4. That vector is the radius of the circle, meaning the terminal point is on the circle. So two parts to this one: graph the point and then draw the vector. Hit pause till you're done. All right, so the graph is not labeled, but in order to go across to the right by 3 and down 4, we can ballpark that, give it our best job. And as long as that point ends up on this circle, and then we can draw the vector, and I've included both components as well. So today we'll be looking some more at using reference triangles to evaluate trig ratios that are unknown. And the key feature of using a reference, two key features of using reference triangles. One is we'll need to identify quadrants, and secondly, we use how to use the reference triangle. So just as a reminder about drawing a reference triangle, the first thing we'll have to do is to determine that quadrant before we can draw our reference triangle. And then we're going to draw a right triangle. The adjacent side goes along the x-axis. We're always going to start at the origin, go across the x-axis either to the left or to the right, and then you'll stop part way out to the edge of the circle, hit your 90-degree angle, and turn either up or down. And once you hit the edge of the circle, that'll be your third point, your third vertex of the triangle. Finish up the triangle. Hypotenuse is always going to be positive, but those other two legs may be positive or negative, depending on which quadrant we are in. And lastly, if you do have a quadrantal angle, either straight to the right, straight left, straight up, or straight down along one of the axes, there's not any possible way to draw a triangle. So you're just going to have a straight line. It'll be like the radius of the circle laying directly on top of the axis. So this is a reminder from that first part of the do now. We were in quadrant 3, and our notes page would be an easy way to determine which of the trig ratios are positive or negative, or we can use that memory device. All students take calculus, and so we know T is the third letter there. So in quadrant 3, from that first part of the do now, we'd be looking at tangent as positive along with its reciprocal cotan. All right, so let's look at an example. If theta is in quadrant 3 and sine of theta equals -2/7, then evaluate the remaining trig functions. Okay, well, quadrant 3, right? That tells us a lot. We don't even have to do any work to figure out which quadrant we're in. It just straight up told us you're in quadrant 3. So I'm going to draw a reference triangle in quadrant 3. I know which quadrant I'm in, so I am ready to go ahead and start drawing. So I'm going to start at the origin, and in order to stay in quadrant 3, that's the lower left, I'm going to have to go to the left across the x-axis. I'm going to go out as far as I feel like going, and then there's my second vertex. Turn and go straight down until I hit the edge of the circle. There's my third vertex. Finish up that triangle with the hypotenuse. Okay, now I'm going to label sides. Get my graph marker up here, so it'll be ready for later. All right, sine. It says sine of theta is -2/7. So I know that sine is the opposite side over the hypotenuse. So I'm going to use that -2 as my opposite side. If you have a negative value to a trig ratio, that negative sign is going to have to go with either the opposite or the adjacent. You can't put it on the hypotenuse because the hypotenuse is always positive. Them's the rules. So this 7 will be my hypotenuse. So I'm going to go ahead and label those. So from the perspective of my graph walker, the opposite side is over here, and the hypotenuse of 7 is going to go here. And I'm going to need to find that missing side length. So I'm going to set up the Pythagorean theorem to find this missing side. We'll call that x. So negative 2 squared plus x squared is 7 squared. I squared all of those, subtracted the 4, and then the square root. So x is going to be radical 45. You could go ahead and use that. I'm going to continue to simplify that radical. I'm going to break 45 apart into its the factor pair that involves the largest perfect square possible. So it's going to be square root of 9 times the square root of 5. Simplify the square root of 9 to get x equals 3 radical 5. So both of these are equivalent. You could use either radical 45 or 3 radical 5. I'm going to do 3 radical 5. Let's just set an example of following proper math conventions. Okay, so now let's think about this for a moment. So we're in quadrant 3. In quadrant 3, my little graph walker, in order to get from the origin out to the end of the vector to that terminal point, my little graph walker is going to have to go to the left. Come on, graph walker. Right, and left is a negative direction across the x-axis. And then my little graph walker would have to go down 2, and that is a negative direction on the y-axis. So my 2 that went down, that's already negative. I got that from the original part of the problem. But this 3 radical 5 that I just wrote in there, after a little bit more thought, I realized that's going to have to be negative. Okay, and my work in the Pythagorean theorem down here doesn't tell me anything about whether that needs to be positive or negative. That's just not the right place to look to find that out. Quadrant 3. Quadrant 3 on a graph means you're going to have a negative x and a negative y coordinate. So I need that negative sign on here. If I'm thinking about components of a vector, or if I'm thinking about the coordinates of this ending point, then negatives make a lot more sense. If you're thinking about, it's the length of a side on a triangle, then negatives don't make any sense, right? And so there is a triangle there, and that is not a helpful way to think about this. So we're going to think about either the coordinates of that terminal point or components of a vector. Okay, well, now that I have all my side lengths filled in, my components or coordinates, now I can put together the 5 remaining trig ratios. So before I start writing anything down, let's just do a little bit of planning ahead. So I am in quadrant 3. The problem told me that, and I have right over here in my notes, I know which trig ratios should be positive and which should be negative. So I'm just going to make some notes for myself ahead of time to make sure that I end up with the correct trig ratios being positive and the correct ones being negative. So tangent and cotangent both should be positive in the end. So I'm just going to make a little note to myself so that when I get there, I double check and make sure that that's worked out right. And then sine, cosecant, cosine, and secant should all be negative. So I'm just going to put some little minus signs over here. Sine already started out as negative. That was provided for me in the first place. So yay. But now let's work on these other ones. So cosine, that's going to be the adjacent side over the hypotenuse. And that'll be negative 3 radical 5. That is my adjacent side. 7 is the hypotenuse. You can just move the negative sign out in front of the entire fraction. So it's a negative fraction, 3 radical 5 over 7, or you could put the negative sign as part of your numerator. Either way is equivalent. But that is a negative fraction. And so I got my negative result like I was supposed to. Let's look at tangent. Tangent is opposite over adjacent, so that would be negative 2 over negative 3 radical 5. And that is a negative divided by a negative. So if I clean this up a little bit, those negatives basically cancel each other out, right? So I'm going to end up with a positive result, which is what I indicated ahead of time I should end up with for tangent. Secant. Secant is the reciprocal of cosine. So I could either just do the reciprocal of what I've already given for cosine, or I also know that cosine is the hypotenuse over the adjacent, so I could recreate that from my side lengths. 7 over negative 3 radical 5. And again, math convention says we should not leave a negative sign as part of a denominator. There's just a lot of things you're not supposed to leave in a denominator. So I could pull that negative sign off of the 3 radical 5 and put it out in front of that entire fraction. You could say, hey, look, positive divided by negative gives me a negative answer, so it's a negative fraction. All right, and that did give me a negative, just like I said ahead of time I was supposed to get. Cosecant, that's the reciprocal of sine, and so I can either do the reciprocal of the original sine value that the problem gave me, or if I wanted to recreate it from my illustration, either way is going to give me the same answer in the end. So cosecant is hypotenuse over opposite. That's 7 over -2. And again, oops, green. I'm going to take that negative sign off the 2 and just put it out in the front of my fraction, because a positive divided by negative does give me a negative answer. And then that -7/2 does match the negative that I indicated ahead of time I should get for cosecant. Lastly, cotangent. Again, 2 options. Is the reciprocal of tangent. I've already written tangent down, so I could just do the reciprocal of what I've already written, or if I want to recreate it from my diagram, I can do that. Cotangent is adjacent over opposite. -3 radical 5 over -2. And again, a positive negative divided by negative gives me a positive result. So I can just erase both of those negative signs, and that gives me a positive answer, which is what I said I should end up with for cotangent. Here's our next example. The point 3, -4 is on the terminal side of theta. Determine the exact values of the 6 trig functions for this angle. So theta refers to an angle. I know that's kind of a strange way to refer to it, as to say this point is on the terminal side of theta. If you remember, an angle is defined in geometry as 2 rays which share a common endpoint, or they start in the same place, right? So I have 2 red rays there drawn in the illustration, one at standard position, starting from 0 on the direction angle, and then the other side would be the terminal side, right? And so the point 3, -4 is on the terminal side. Okay, well, I don't actually need this one. But in order to get to the point 3, -4, I'm going to need to go to the right by 3. And I'm going to need to go down 4. So there is my reference triangle. I've got one side of 3, one side going down 4, and then the radius of the circle is the vector connecting the origin to the point 3, -4. So the other way you could think of it is to say, well, the point 3, -4 is on the terminal side of the angle. Well, it also, that point is going to be the terminal point of the vector starting at the origin. So, and either way, we've got our illustration. We've got a reference triangle just by drawing the 3 and -4 as components for our vector. And that tells us that we're going to be in quadrant 4. And in order to get myself the rest of the way ready for evaluating the 6 trig ratios, I'm going to have to find that missing side length of my triangle. So you might recognize this as a Pythagorean triple. I do, but you also might just want to set up the Pythagorean theorem. So 9 plus 16 equals c squared. That'll be 25 equals c squared. And then square root both sides to get 5. All right, and I ended up in green, which is not really the color I wanted. But there's my hypotenuse. It's going to have a length of 5. And maybe just to help this visualization out here, there's my little graph walker standing at the origin. So this is going to be the adjacent side, the opposite side, and that one's the hypotenuse. Right. So I am now ready to create all of my trig ratios. Sine is the opposite, so it's going to be -4 over 5. Cosecant is the reciprocal of that. That'd be an easy thing to do next. So I'm going to have still a negative fraction. I'm going to put the hypotenuse 5 on the top and 4 on the bottom. Next would be cosine. Cosine is the adjacent side, which is positive 3 over the hypotenuse of 5. And let's do the reciprocal secant. It's going to be 5 over 3. And next, we got tangent. It's the opposite over the adjacent. So negative 4 over 3. And cotangent is the reciprocal. So I'm going to have the 3 on the numerator, 4 as my denominator. I'm going to put that negative sign out in front of the whole entire fraction, so I don't have a negative denominator. And then we could check our signs, which ones are positive, which ones are negative. So we ended up in quadrant 4 this time. This is quadrant 4 down here. And in quadrant 4, that'd be all students take calculus. It's the C of all students take calculus. So cosine. Cosine should be positive along with its reciprocal. And that is, in fact, what I got in my results already. Cosine is positive. The reciprocal secant is also positive. And the 4 other trig ratios are all negative.